All right. Hello, everyone. This is an introduction to Arduino and C programming. So let me talk a little bit more about myself before I get into things. My name is Nguyen. I am a second-year computer science student here at the University of Cincinnati, and I'm also minoring math. I am currently on co-op at 8451 in Cincinnati as a software engineer, and which is clearly what I want to do in the future. And so this is why I'm presenting to you guys mainly about programming. Some of the current leadership positions that allow me to get where I am, as well as why the reason I'm talking to you, is that I am the vice president of UC CubeCats, an aerospace mainly, and like kind of more just everything general machining student organization on UC. And if you also know me from ACMW, where I'm also the volunteering chair, I pretty much run along with another person, Bearcat Coders. So if you guys are in that, I'm also one of the people leading that. I'm also a Darwin T. Turner ambassador. So let's actually get into the presentation which I'm talking about, which is Arduinos. So I do make some assumptions into here while I'm starting this out, just to make sure that you guys kind of get into the flow of things. I do assume that you guys are currently or are taking one programming course currently. It should be required at this point if you are a first-year student. So I think you guys should be good. And the goal of this entire presentation is for you to get used to Arduinos and programming, and such things as adding shields, which are accessories and attachments, adding libraries, using control flow, using functions, reading connection diagrams, and debugging applications. If you do have an Arduino on you right now, this presentation is interactive. And so if you go to this GitHub link right here, you can find everything that I am talking about, as well as what I'm doing during the presentation. Hopefully everything's good. That's good. And so let's start off with the first thing is introduction to Arduino hardware. Arduinos can be a little bit complicated when you first see them. And so you can easily get confused about all these different pins and whatnot. And here are some of the Arduino models. The two most important ones and the ones that are most used are the Arduino Uno and Mega, but they do have 4 other variants, the LilyPad, the BT, the Nano, and the Mini. But all of them are used in different areas and sections. And so the most popular one is the Arduino Uno, so that's the one I'll be focusing on this presentation. And so when you first take a look at Arduino Uno, if you've never seen it before, it kind of looks like a mess if you never touched with microcontrollers. Everything is everywhere, there's a bunch of numbers everywhere, and you absolutely have no idea what the heck is going on. And so really, there's only 4 main lights that you really need to understand about what's going on in here, as well as some of the pins. So the 4 lights on the Arduino, there is an on light. So sometimes you need to understand if it's on or off, since there is no actual graphical user interface, if you're not connected to a computer. There's a TX light, which shows that if data is being transmitted, such as if you have a sensor being connected to there. There's an RX light, which you can see here. Both these are labeled. And the RX light shows that data is being received. And so if you're outputting or just sending things in through a sensor, that's where it'll be flashing. And there's also a L light, which is just a regular LED that you use. However, for those who do really need a graphical user interface, most of the times you would use a serial port, which is a USB-B, which is not really commonly used, but it comes in the box with Arduinos. And so when you connect that to your computer, you can get something, if I can see it, like this. If you download the IDE, where it will show you pretty much a coding interface that you can interact with the Arduino itself. And if you already have a program uploaded straight into this Arduino, since it does have a limited amount of memory to store programs, all you need is an external power source, and pressing the button on the top left, which is this little white one, will actually just immediately start up the program that you have saved on there. So let's talk about accessories. Accessories are what makes Arduino so customizable and so powerful. The accessories usually include, within the box, it's just an USB A to B cable and an external power source. Sometimes it comes with a breadboard. There are sometimes resistors and variable resistors, such as potentiometers, switches, wires, sensors, and motors, depending on the different packages that you buy. Shields, as I said earlier, are add-ons and accessories that extend the functionality of Arduino. And usually there's already some type of code or example written for them. And some of the examples of different shields are like Ethernet shields, LCD shields. There's even camera shields where you can take photos just automatically using your Arduino. motor shields, which allow you just control servos and motors, and different other types of prototypes that are used anywhere. And many of these shields can include Bluetooth and just extend the functionality of the Arduino, not even including sensors. And if you've taken a computer architecture class, a lot of Arduinos are really similar in how they're built, with the CPU having an ALU, registers, and controls and counters, but usually you don't interact with these very much since you're really only dealing with sensors. And the memory, there is flash SRAM EEPROM. EEPROM is one of the few memory things I'll be talking about, since it's also one of the storage ways that you can store on Arduino without having to connect a shield, such as a SD card shield, where you can attach and use an SD card included on it. And then we have the I/O interface. And so let's get into the programming bit of this, where we'll talk about the IDE, variables, operands, and serial monitor. So the Arduino IDE, which you just briefly saw earlier, you can get this from the Arduino's main website. And the funny thing is the IDE is actually written in Java. However, the Arduino only accepts programs written in C, which actually doesn't make any sense. But you also have to compile the program in C, since it only accepts programs in C. So the IDE mainly acts as a C compiler. On the top left of the IDE, you see 5 different buttons. Starting left to right, there's a verify, there's an upload. Verify just checks the syntax. So standard IDE stuff, upload actually uploads your file that you've which they usually call sketches, straight into the Arduino and saves it on the hard drive. So as I said earlier, if you just add a power source and press the white button on the top left, you can just automatically run it without using an actual interface. And then the other 3 buttons are mainly just saving, opening, and creating a new program. But when you do get the Arduino board attached, you do have to choose Arduino board and port that you are connected to onto your computer, because sometimes it can get really confused about wiring and getting into your computer. And so that's why you should always just make sure that if you go to Tools and to the Tools tab, you make sure that it's what you have connected to your computer. So on my computer, it should say that I am connected to an Arduino Uno, which I currently am right here, as well as that the port is COM3, which is just the standard output port, which we'll talk a little bit more later about. So getting to the programming bit of this, how are Arduino programs structured? They're structured in a very simple way, where there's 2 required components. There's a setup part and a loop part. Setup is where your code will run once, and you'll pretty much set up anything that's connected to your Arduino. So that would be setting up the sensors and making sure that they exist and the Arduino board can see them, as well as setting up any global variables that you might use later on. Loop is, as the name implies, is a loop which will run repeatedly, non-stop, no matter what happens. And the only way that you can actually stop this loop is actually shutting off your Arduino completely, which makes also no sense, or pressing the white button, which resets the program. But then since you're resetting the program, you're running the program again. So it's a little bit janky, but that's how they do it. And usually when I do things, I just unplug the power switch. It actually doesn't hurt if you unplug the power switch and everything powers off, because that just stops it, and everything should still be written into whatever you've written into. And so in terms of declaring and instantiating variables, it is fairly simple. It is just the data type. So it would be like, for example, int, and then you would have the variable name that you have attached to it, and then semicolon. So if you've taken a C++ class, this looks identical to C++, and it should be identical to C++ in terms of pretty much every syntax there. You can also instantiate a variable together simultaneously in declaring it. So int year is equal to 2017, even though it is in 2017, as well as make constants, which is also integrated in Arduino C. In terms of scope of variables, scoping is roughly the same in terms of C++ and Arduino C. They are 1-for-1. Variable scopes pretty much determine if you already know what scoping is, it just determines the variable, where the variable can be used and cannot be used. Local variables can only be used inside functions. If you declare a variable inside of the function, it can only be used in the function. And global variables, which are static variables, If you just declare them in the main code, you can use them in all functions. And you usually see them, as I said earlier, in the setup phase where you are declaring everything that you might be using. In terms of math operators, all math operators are roughly the same in every other programming language. There's ints, floats. You can declare ints and floats, and addition and subtraction work the same. I believe you can also add floats and ints together, and the result will be a float. So that's one good thing about Arduino C, but usually that's how it should be done. And so these are all the different math operators that you can use. It's usually the same ones that you usually see. And here's the really important part. Since there is actually no place where you can declare, like write in commands, there's something called the serial monitor. The serial monitor allows you to output the program. And so in the setup, by setting up your serial monitor, it actually allows you to see what's going on inside of the Arduino and just see some of the things that are being output. So that's how you would print line, like hello world, basic hello world. So to set that up, you'd have to start with a serial.begin, and there's something called baud rate. Baud rate is the speed of connection, usually just the default baud rate is 9600, and usually that refers to the connection between your computer and your Arduino, and so that's usually limited by your wire. But usually the one that comes in the box is 9600, and it's usually gated. If you do a higher one, it won't hurt anything, but it will just reset back down to the highest possible baud rate that is available on your Arduino. By printing to the serial monitor, you can do serial.print, which does not do a new line, and so it's just prints in a constant motion. Or you can do serial.println, and then whatever you're printing out, and it does do a print for every new line. You can also work with time in here. There are built-in delay variables. You don't have to import any library for that. There's just delayed by microseconds, micros, which returns the number of microseconds since the Arduino was reset. So pressing the white button, how long it's been since you pressed the white button, and milliseconds, which is the same thing, but in terms of milliseconds. So output on the serial monitor. So you would have, this is pretty much just a really quick example. You do serial.begin the baud rate, since baud rate is normally 9600. That's why I said it in this example. And in a loop, you're just adding these two variables, an int and a float. And when you add them together, you can do serial.println, and it ends up 7.56, which is the expected value. And that runs on continuously forever since it is in loop. And these are some of there's also advanced math functions that are built into Arduino, such as absolute value, constraint, which people rarely use, cost and tan, square root, min, max, power, and map, which isn't really used that often either. And map and constraint are really only used for sensors to make sure that it keeps it within the values that you're expecting. And you can also generate random numbers. So that's also built into Arduino using the random function as well as random seed to ensure that just a random seed is used and it's actually truly random. And so let's actually get into an example of using the serial monitor. So in the top right, as I said earlier, you can press serial monitor. In setup, I do setup.begin. Since I don't want it to loop on forever and have it running in the background and killing my computer, I do actually run everything in setup, so it only runs once. And so I set section equal to 1 since I'm doing different sections in one program. This is the example I showed you guys earlier, an int plus a float in a serial output, and then delaying it by, actually, I don't know why I have the delay in here, but just delaying it. And so if I just upload this straight into my Arduino, which it should, you can see here that it outputs 7.56, which is your expected value. And so you always have to start up with serial.begin to make sure that this always outputs into the serial monitor.
Hey, excuse me.
Yep.
Are you able to expand any of these windows?
Yes, maybe. This is the sucky part about this.
You do control plus and
yeah. Sick. Is that good?
Yep. Thank you so
Perfect.
much.
Nice. So getting back into this, let's get a little bit into control flow. Control flow is roughly the same as Arduino as in C++ if you're currently taking C++. Same style of if control, if else, as well as if else if, and then else. And so if you've already seen this before, it shouldn't be anything new. If you haven't, it's fairly similar. In terms of numeric comparisons, the equal signs and not equals. The only one that doesn't look, that it also has two different not equal signs, even though they do the exact same thing. So whichever one you're used to, I know programming languages implement different things, such as just the two other, the weird equals, the less than and greater than. We do also have greater than equal, so all the normal numerical comparisons. So you can always put this in conditionals. And you can also do compound conditionals using pipe statements and, which is really similar to C++. And you can also do negation, which is just adding the exclamation point and doing, which gives the opposite of what's going on. And for those that are well-versed, there are switch statements in C++. I mean, Arduino C, which do the exact same thing as C++, and make sure you have a default case or you have problems. Yes.
So is the syntax for Arduino C or for Arduino essentially just C syntax with a couple of different
Yeah, it pretty much is. I think the more interesting part is getting used to sensors. The sensors can sometimes be really janky because they come with their own libraries and different things. So most of the syntax is roughly the same as C++ though. In terms of loops, the loops there are 4 whiles and do whiles. I haven't seen anyone use a do while in a long time, but they do exist. But mainly you use for and while loops. It is set up the same way as C++, where you have your initial value, what your restraint is, as well as your counter increasing or decrement. And so it's just outputs whatever's inside the for or while loop that is inside the brackets. You can also use multiple variables within loops. So you can declare 2 variables within your for and while loops and do a double increment or double decrement or however you want to do each one. And you would have only one of those be impacted by your restraint. So you can only have like one condition. So A is less than 10, but you can't have A is less than 10 and B is greater than 10. It's just whichever one ends up happening first. And then you can also have nested loops, which is fairly simple, just doing 2 for loops with inside each other. So standard stuff usually. You do also have break statements and continue statements. Break statements are used to break out of the loop if some sort of threshold is it. And a continue statement is just making it just jumps out of the loop and goes on to the next iteration and skipping everything after the control statement. In terms of arrays and strings, arrays are built in the same way as normal arrays, where it's a block of memory. As I said earlier, you do have access to some of the deeper dive into Arduino and some of the microcontrollers within it and registers. So if you do want to do some pointer stuff and have fun with that, you can access arrays by not just indexing it. You can also do the ++ and do some of the more fun stuff with a memory allocation, which I don't think anyone really wants to mess with memory allocation in case you want a seg fault, which this one does have. The array stores multiple data values, which is a really nice thing of the same data type in the block of memory, so it allows you to reference it. So the key word here is same data type. It's not like Python where you can store different data values like a string and an int in a list. So you have to make sure that they're all the same thing. So you can only store 10 ints. The declaration is the same as C++, where you'd have the data type, the variable name, as well as how big you want the sizes. There are no variable arrays in Arduino, so there is no library that is included in this. I'm pretty sure there is libraries that you can install to have variable arrays that act like lists. So that's pretty much it. But you always do need to determine the size of the array. So size equals the size of. So if you want to determine the size, you'd have to actually do it the C way, where you're seeing the size of the array dividing by how big the size of an int is. which is a really weird way. That's how they do it in terms of blocks. And so the example for this that I written down was just doing a counter or it equals to 0 and having some imaginary array and having it run through the entirety of the array based off of how big the size of the array is divided by how big of the size of an int is. I do have challenge questions, which you guys can attempt, but for the sake of time, I won't let you guys go through the pain of doing these. Do you like challenges? Go ahead. I'll let you get through challenge question 1 if you really wanted to. It's structured a lot like a test exam, which I wasn't actually trying to do, but when I looked at it last night, I'm like, that's actually kind of rude. Because I'm guessing you guys, if you guys are freshmen, probably have C++ exams upcoming, so I don't want to give you PTSD from having to do those. Hmm? No, it's not multiple choice. That's why you, yes.
Just one question about the size of it. Do arrays are share metadata on the length of that size of, or just?
I believe I don't think it stores the metadata. It just actually reads where the start of the pointer is and then until the end. And then that's how it gets its size. And you just divide it by. So I think that's how they implement it in C++ as well. So I think too bad. That's good. So the good thing about Arduino C is that there are string methods. C++ doesn't really have that many string methods attached to it. So you would have a format. So the format is just a string. You don't have to do the C++ way of doing strings where it's the importing strings library. And so you can just straight up declare strings and it'll create a line of strings. And then you can use these different methods in there, such as like character at, compare to, concatenate by concatenating two strings, ends with, equals, get bytes, which isn't really used that often, but it's really good if you're doing more low level stuff, index of, and then last index of. And then all these are really good for manipulating strings. If you're using manipulating strings, it's probably because you did too much leak code and you shouldn't be doing that because you are going to die on the inside. There's a lot more string functions. The last slide had quite a bit. There's like replace starts with substrings. There's also a really fun one called toInt, where you're converting a string into an int, which I still don't understand how that works. I think it's something with just going through the, I don't remember how it works, but it's just a fun way of doing it. I've just had a bunch of fun just doing random strings to int. But yeah. Strings are just car arrays, by the way. It's the same implementation of it. Is it raining? Well, that walk's gonna be fun. In terms of functions, Arduino does have functions. Each function has a data type, so the data type indicates the return statement and what type you're returning. There's also void data type where you're not returning anything, so standard stuff. You'll often be using this if you're doing a lot of stuff with sensors, because sensors can get quite repetitive a lot of the time. And so when you're just putting in sensor data and just reading sensor data, it's sometimes good to just do a different function for each sensor, because you could maybe be working with like 10 different sensors sometimes, or even just 10 different shields with cameras on them. And so doing things in chunks of functions really makes your workflow more composable. And usually if you're working in industry, composability is something that everyone's striving to work for, and making sure that things aren't just repeated. For using a function is fairly simple. You do have to set it up in your function and reference it in setup. So usually you declare your function before setup, then you do it, and then you declare the function in setup to make sure that it reads this function and make sure that the Arduino understands the function exists. And when you're returning a value, it is the same idea of when you're making the return statement. You just have return and then whatever that data value, and has to match the type that you add on to your function. So int my function2 should return an int. And then passing values to functions. It's the standard stuff with parameters. By creating parameters in your functions, you can pass them in as arguments, and that'll just pass in the arguments into the main function and then return in the value what you have in your return statement. So for example, if you're doing area of a square, it should be like your arguments will be 10 and 20. So 10 times 20 is 200. And so you would return out 200. So standard stuff within a program in terms of functions. By handling variables inside of functions, as I said earlier, there is scope. So most of the scope is inside functions are local variables. And so local variables would be just to declare in the function. But if you want global variables, you have to declare them outside of the function and inside setup. And so that would ensure that it is a global variable. And if you want to do a constant global variable, you want to define them even before the setup loop, just above the setup loop, so it can be used as a constant. There's also recursion. Arduino does handle recursion and handles recursion actually pretty well. It's just when recursion is when the function calls itself, if you don't know what recursion is, and it usually has a base value, which kind of adds up into a cascading form where you just get the value. I do have a demo for this one. Yes.
Does Arduino see have a maximum version depth?
It's 1,000, I think.
Sorry?
I think it's 1,000 like iterations.
Okay.
If I remember correctly. I could be wrong. You can set your max recursion depth, but I didn't include it in this one.
Okay.
Access denied. Why is access denied? COM3 port busy. Oh no. It's because But yeah. The interesting thing about Arduino is that you can't have two Arduino things occurring at the same time. And so you'll get the same error that I just did, where it says the port is busy. That means that one of the things are still technically running and stored onto the Arduino. And so you have to store everything at once on the Arduino. So that kind of makes sometimes things very long. And so you'd have to, in theory, create your own library to add it into Arduino and have it run. The way this uploads to Arduino is that it actually uploads, I believe, the bytecode into it. So when you create a library, it will actually just create the entire long script with the include at the very top and just make one large exe that is sent into the Arduino. And it can only handle one of those at a time. So now when I press upload, it won't give me the port is busy error, and actually gets you through some of the things that it actually lets you execute the code that you want to execute. So this one just asks you what the factorial is. I have two global variables set up here, as well as a local variable set up in factorial, so if I try to call this result in setup, for example, I would not be able to call it, and it would say that either the scope doesn't exist or the variable itself doesn't exist. So this is a fairly simple factorial function. The fun thing is you can actually set up the function after the setup where you're declaring factorial. And so it doesn't actually really care much about what is going on. Most of the time, it actually reads through the entire code first before it actually starts doing any of the setup and loop functions. Cool. If you want to get into thin of things, you can also set up structs. There are no classes within Arduino C, even though the syntax is very similar to C++. It is called Arduino C for a reason, since it's all mainly based in C. And so what you'll be using is structs. Structs is you are just general custom data types that group related data elements together into a single object. And so if you're going for object-oriented programming, this is somewhat similar way of doing it if you're used to that. But before you can use a data structure, you have to define it. So it's kind of similar to a function. And so a struct would just be something like this. There are unions, which also kind of mimic the same way structs do work, as well as templates within C++. And so unions allow you to have a variable take on different data types, which is a really absurd concept, but you can call a float inside union, and then you can kind of call it as a method to set up values within the union that you can use later on. So for example, on the right is an example where you have a union where you have a float, which is an analog input, as well as an int, which is a digital input, and the class name would be sensor input. And then you would save values into that union based off of, if you, for example, made a function like function 1 and function 2, and you'd save analog input, the result of function 1, and digital input as the result of function 2. And then later on in your code, if you want to use those values that you got from function 1 and function 2, you would just call the union, so sensor input, and then you just kind of call it as a method, so dot analog input to get what the value was you stored from function 1. In terms of libraries, we'll get into libraries, I/O, connection diagrams, EEPROM, which is the main thick and thin of things, where you'll be kind of getting nitty-gritty into some of the sensor stuff. Libraries are what allow you to bundle related functions into a single file. Every sensor that you ever buy will have a library come attached to it, so you'll have to download sometimes multiple libraries for each sensor for it to work. And so instead of having to rewrite the functions and pretty much write the functions from scratch for things, you can just use the library that they attach to. Some libraries include that are already set up in Arduino when you get it out of the bag are EEPROM and library header. And you can reference library functions by just the library name dot whatever functions inside of it. And if you want to install a library, you have to open up your IDE, and then inside of the menu bar, you can import a library through one of your submenus, and then you just press add library. And as I said earlier, some of the examples of libraries that are included are EEPROM, which is used pretty often. There's also software serial. We also used one earlier for serial, where you're just setting up a serial monitor. There's also Wi-Fi, but you do have to have a Wi-Fi shield on it. But usually that sometimes comes attached with different packages that you buy from Arduino. So yeah. And in terms of the input and output layout, aside from the LEDs that I showed you earlier, there are different input and outputs. There's digital and analog pins. Digital pins are the ones that you usually use. Digital referring to like zeros and ones, and analog being just kind of constant data that is not exactly zeros and ones. And so if you're using a sensor, most of the time it will be working through digital pins, since that's how it will be sending the data straight to your Arduino. As I said earlier, there's a USB jack as well as a DC power jack. There's a 16 megahertz crystal that is mainly used for timekeeping. The USB to serial IC is mainly just a service bus to get all the data in. Then the TX-RX LED that I was talking about earlier. There's also the power LED that I was talking about earlier. And then the main core brain of things is the Atmel AT Mega 328, which is essentially the CPU of the Arduino. There's also, I forgot to say, there's a resettable fuse. If you do put too much power into your Arduino, there is a breaker attached to it, so it will actually flip that switch, and everything will shut off immediately, and nothing will work. And so you'll have to reset that fuse. I don't remember how to, but it's really rare that you ever have to reset that fuse, and you can run it again. And so when you do get sensors, you do have to initialize the pin that you're going on. Since most of the time they use digital pins, you would have to do something called pin mode, where you'd set up the pin that you're attaching your sensor to. For example, you're choosing digital pin number 2. You do pin mode 2, and then the mode that you're doing, so it would be input or output. And so if you're getting data from your sensor, you do input. But if you're sending something out to, for example, a screen, you'd want to put that as output. Yes?
So are A1 input and output reserved ports here?
Yeah. So getting a reading from an input device, you can also do analog.read pin. So you don't have to get through the pin mode method, but usually no one really uses that way. And so, for example, in a setup would be the one that you see on the right, where it would be sorry, if you do use analog read, I was thinking about something else. It would be just void setup, and then you're setting up the serial so you can see what's being output to your screen, as well as pin mode to so the Arduino knows what your sensor is connected to and what pin specifically it needs to read to. And then the loop is where you'd be getting your reading from. And so you do analog read from the pin that you already set up earlier. So A1. The good thing about Arduino and the sensors that you do buy, most of the times they do come with connection diagrams. So this is an SD card connection diagram. And this is the one that's specifically made for the Mega. They will come with one for the Mega and one for the Arduino Uno, since those are the two most used ones. And so even if you don't understand what it says on the right when you're actually looking at the chip, for example, SD card, you see SDK, MOSI, MISO. Sometimes that doesn't really make sense if you never worked with this, but VCC and GND. GND usually stands for ground, VCC is your power. And the rest, the other four are usually pretty interchangeable. So a lot of times it's really confusing about how you're connecting things. But that's the good thing about Arduino is that there's a really nice community of people who are willing to help you out and just do these connection diagrams for you automatically. And so, as I said earlier, if you don't have anything for, like for example, SD card here, that's connected to Arduino Mega, there is EEPROM, which is the built-in flash storage within the Arduino for long-term memory. It keeps data stored when it's powered off, similar to a USB drive. And so the way you do it is, since it's one of the libraries included with the Arduino, when you get it out of the package, you just do #include EEPROM with the header on it. And then once you include that, you have access to the commands read, write. And so on the right, you would have #include EEPROM. You would set up the EEPROMs so it can write things constantly. And then I didn't really do anything for loop. I don't know what happened there. But this would be just writing it. Yes.
For EEPROM memory, when it says that it becomes unreliable after 100,000 writes, is that purely because it runs out of memory and is forced to overwrite, or is it because hardware-wise there's something that goes wrong?
It's kind of similar to, I think, SSD, where if you write it too many times, or is it hard drive? I can't remember. It's one of the two, but it works a similar way where if you write it too many times, it sometimes just doesn't refresh the pin, I believe. And so I don't think it does have the capability of refreshing the pin all the time.
All right, so it's just like if I wrote it out and then freed up that memory, I took that 1,000 times, it's still.
Yeah, it would still be fine. So it's just that block of memory.
Okay.
Yep.
How big is it typically?
What do you mean?
Like how many bytes?
It depends. I think the Arduino Uno is, it actually does say here when you're uploading it, but I think it's only a couple 100 megabytes. So it's actually not a lot. So to show you, Arduino section, Arduino, I have two different Arduino sections, one for writing. And so I'll be writing this data, and it will tell me that I've written it to EEPROM. So now it's actually pretty fast writing to EEPROM since it is flash memory. I can completely exit out of this and as a completely different Arduino just program itself. We can read EEPROM just directly, and it should show up. Hopefully, if I didn't make this up, yeah. So I wrote 10 through 50. I can actually go back to the old one since this is not being used. Since I was writing everything that I stored in this list, this array, 10 through 50, straight into EEPROM, I wrote out 10 through 50, and then now reading it from EEPROM, I get the values that I did write in there, even though there are two separate entities and two separate programs. I am able to read the things that I store in EEPROM. So it does work, and it's always included. If I did this another 100,000 times, you probably wouldn't see any of these values. Well, you probably would see them, but it just wouldn't change the values if I tried inputting anything else. Or sometimes it does give an error, but I haven't seen that in a long, long time. There's also a debugger included in your application. It is not a command line, so you can't actually type anything into it, but it will tell you any errors that do occur, such as if you're missing a semicolon. So it is a very nice and intuitive debugger, and it's not like Java where you get 3 million different lines at the same time. And so that's, at least it's really nice, and it'll give you the actual line where it is erroring out. Sometimes it's not actually accurate, so similar to C++, and it's the line above it that is incorrect. And it'll also highlight the error that it assumes where the error is caused. So, for example, here it does say delay 2000 is missing a semicolon, even though the one above it is missing the semicolon, since it's just a simple semicolon error. And so let's combine it together. As you saw here, I do have my Arduino here, but I also do have a sensor that I did bring of my own. This is a humidity and temperature sensor. And so this is an Arduino Mega and a humidity temperature sensor. And some of the required knowledge, it's really simple code. It's just using a library, understanding connection diagrams, loops, control flow. As I said earlier, every time you buy a sensor, for example, this sensor, it always comes with some sort of data sheet. And so I actually didn't really have to worry about the wiring in terms of this. And I did make my own. So this is the example of, this is an Alsong AM302, even though this is 303, that's the updated version. This is roughly the same thing, and usually when you download this, buy this, it will come with a paper that tells you a link to where to go to understand what's going on. It'll give you all the different dimensions of what's going on inside this sensor. For example, what each one does. So VDD here, which is on, you guys can't see it since it's really tiny. This refers to your power, as well as some of the operating temperatures that you can work in, as well as the different error that you get depending on when you're reading material or doing a reading. Hopefully, if I can find it. I don't think this is probably not around. But yes, it does say this in terms of supplies. It will tell you what serial data pin to tell. There's also example code that usually comes along with these data sheets that are on a different link. But besides the fact, let's actually get into the example of this. Arduino is really simple to use, and really, like, it shouldn't be scary if you're getting used to these. And so a lot of the times is you just have to understand how this works and how the wiring is. As I said earlier, VCC and GND are just ground and power. So VCC is power. And so if you have those two, now you only need to figure out what the other two are. And so SIG, if you can kind of understand what the abbreviation is, SIG stands for signal. And so if you're trying to get a signal straight into your power, from this sensor, you would just put it into a digital pin, as I said earlier. And so you just initialize the digital pin. So here I would initialize the DHT sensor and do some of the setup. So I do want to see what's being output onto the serial monitor, as well as printing out that these are working. And also inside the library, if you usually have to actually dig into the library, you just do dht.begin is one of the commands to get this up and running. And inside the loop is very simple stuff. The two ways to read humidity and temperature through the sensor, through the library, is literally just .read humidity and .read temperature. So you don't have to do any crazy janky math or do any actual difficult work. Most of it is done in the background using your library. Yes.
So if you wanted to go rogue with it, will some of this be in like the data sheet that's provided with the sensor?
Actually, so the cool thing about this is, even if the data sheet isn't good, to be honest, the data sheet that they provide you for this one is not that great. And so you can honestly just search up so if you just look on this and it says AM2302, Arduino data sheet, most of the times you can just find a bunch of different data sheets for this. And so they'll actually give you sometimes more data, different types of data that is attached to this. So this one doesn't give you wiring, but you can go to, for example, this electro schematics one, which kind of tells you the different specifications. But the one that I also use for this is this Mauser one, which is really handy because it kind of gives you a really simple way of understanding what everything's going on. And Here, it even shows you the wiring. So just searching up the sensor online, there's probably a bunch of different people and a bunch of different companies that have used this type of sensor before, since this is also used sometimes in different agencies and whatnot, just as testing purposes. And so this, I recommend doing it 5 volt. I'm doing 3 volt for this one, but there's usually isn't a difference. And sometimes it'll tell you some of the better wiring, because the way I do it is 1-to-1, but here actually asks you to do a resistor, I believe. So yeah.
So is the only way to get the code for it to use Arduino libraries though?
Yes. Usually you can do the same thing on Google. You just search up library, and so it will tell. Sometimes websites will just lead you directly to the library and where to download it. There's also like different things that people have done. So it seems like a fan plus the sensor. And so if you want to do projects with it, there's also even code attached to this to tell you to just do simple things that make it easier for you. If you want to just copy what their format is 1-to-1 and see what their project is like. So there's a lot of ways to just get into the program itself and just start coding. And so since I followed the Mauser example, I actually followed the wiring for the Mauser example, since I haven't used this in a while and I didn't remember how the wiring was. I actually followed their example, and I wrote a really simple, quick code for this where I'm just reading humidity and temperature at the same time. I'm making sure that this is just a sanity check to make sure that this exists and that I didn't wire this completely wrong. And then I'm just printing out the temperature in terms of temperature in Celsius as well as in Fahrenheit, the heat index, as well as what the humidity is. And so if I run this, hopefully it doesn't fail on me, presumably. Library, and see, immediately it is outputting our temperature. Our temperature are in Celsius and Fahrenheit, what the relative humidity is, the heat index in both Celsius and Fahrenheit. If I blow into this, it should hopefully spike. See, 99% because I'm breathing in, breathing out, and it also increased in temperature a little bit. So working with sensors isn't really anything too scary. Sometimes it's more of switching up the code to move around what digital pins you're interacting the sensor with. Yep.
So is there a way to make it read at a slower rate or a faster rate?
Yeah. So the easiest way to do it, and the way I usually do it, is just changing the delay. So just since it only really, the way it reads is there's no way of changing like how long it's taking the reading for and doing an average. You can also do the same thing by doing a shorter delay and creating an average and printing it out like every 5 seconds by doing like an if statement if you're on this interval. So that's the way I would do it. Sometimes libraries do have do include changing how long the sensor is actually reading it for, but usually you just have to dig around the library and kind of change it. Since you are downloading the library, you can change how the library functions, but I wouldn't recommend it because sometimes it is spaghetti code, because not everyone is expecting to, I guess, that someone's going really in depth of what's going on and just using this sensor at face value. But that's pretty much it. Hopefully that kind of makes sense and you're not too worried about it. If you do, I'll keep this up and running for the entire time we're here. So if you want to mess around with it after this presentation, go ahead. And so after running it, I do have some shameless promotion. So at the beginning, I didn't state who we are. So the reason I'm here is because I'm the vice president of UC CubeCats. So what is UC CubeCats? UC CubeCats is the University of Cincinnati's premier air and space technology student organization. We work on 2 projects every year, one being our freshman/sophomore project, and our other one being our NASA-sponsored satellite, which will be launching in around 2 years. So if you want to have your name on a satellite that'll be in this space for quite a bit of time, do hit us up. Most of our work does deal with microcontrollers like Arduino, so a lot of programming is involved. So if you're interested in joining, reach out to my email. I do want to get into our current projects. This year's freshman and sophomore project is called Project Floppa. We are cat-based, so that's why we name everything after cats. That is what our freshman project, those two, helped choose the name. So as I said earlier, every year we do a freshman sophomore project. It usually involves sending a payload on a high altitude balloon, similar to the ones that China sent over the United States and got shot down. Hopefully we don't get shot down, but that's a different story. Actually, funny story, there is a man-made a high altitude balloon that was doing somewhat of a similar project to us that did get shot down by the US military. So we do have to work with the FAA on those stuff. But what they're doing this year is trying to capture 360-degree footage using a camera, capturing water directly from a cloud. So using a humidity sensor to detect if they are in a cloud, and using a Peltier chip to just collect the condensation that comes from the cloud, as well as recording the amount of air pollution in the area. So using a bunch of different Arduino sensors and just interacting with the atmosphere around them. In terms of the NASA-sponsored project, which is called LeopardSat, for the last 3 years we've been working on this, which is our NASA-sponsored satellite, which is expected to launch in 2 years. The goal of the satellite is to test different carbon-based materials to see which one blocks out radiation the best. This project is actually pretty looked after by NASA, since it really changes how we build spacecrafts in the future, especially long-haul flights. For example, to Mars, so we make sure that our astronauts don't die of radiation poisoning for some reason, which is unlikely, but we don't want to take any chances on that. And so the main objectives that we're trying to do is ensure the satellite can withstand harsh environments of space. So that's more mechanical stuff if you're trying to do design. We're also designing and manufacturing our own circuit boards with sensors to detect radiation. So if you've ever want to get your hands and just design your own circuit board with a team of seniors, which we do senior design projects with, definitely is the best way to get your hands on a really high impact project. And we also do design a software system to gather the sensitive data for radiations as well as the vitals of the satellite. And we have to relay it back to NASA as well as us just for safekeeping. And that's pretty much it. If you have questions about anything, do tell me. If you have a question after the meeting and you just remembered it, these are my socials. So that's my Instagram, my LinkedIn, do increase the amount of connections I have, as well as my email from earlier if you do have any questions regarding Arduino, and I'll try to help you out as best as I can. But if you have any questions now, feel free to ask me and I'll answer them to the best of my ability. Yes.
This is kind of a side question, but I just noticed in profile. Is your GitHub using a Nathan.png?
No. Because that one was taken. Yeah. Too many people taking usernames. Any other questions? Yes.
So the freshman and sophomore project at CubeCats, so how does the project structure?
So it's a year-long project. And so we have two teams. There's a software and payload team that deals with this, that works with the Arduinos as well as the software. And so they'll mess around with the GoPro Max, which is capturing the 360 camera. And so automating so it stops footage at a certain time, as well as collecting some of the sensor data and activating and doing some of the wiring for the Peltier chip, since all of the Peltier chip as well as humidity and water condensation is built in-house. In terms of, we also have another team called, which is called Structures, and just aerospace. It's mainly working on the box as well as building up a high altitude balloon. So it's FAA regulations, so we don't get shot down, as I said earlier, as well as making sure that it hits the right height and making sure that we hit some of the different points within the flight to ensure that we collect the data that we want to collect. Yes.
What would you say is the most interesting or maybe most challenging issue that you've dealt with, particularly regarding deploying these Arduinos high altitude workspace?
So a lot of the issues is actually temperature regulation, as well as just the uncertainty of putting it up into the air. We did have a one time where we sent our high altitude balloon in Kentucky and it ended up in West Virginia. So the scary part is wind patterns change really fast and really rapidly. And so you would have to drive all the way to West Virginia. Sometimes they're unrecoverable because I think that one was in the Appalachian Mountains. But sometimes they do end up near Cincinnati, which you kind of do predict based on the day and using different technologies and tools to predict the landing pattern of it. And so unpredictability is always the worst part, but also operating temperatures, since it gets up into the negative degrees, when you're that high up, sometimes things don't work the same way that they're supposed to, and they kind of glitch out and fizzle out. And so you have to deal with that kind of erroneous data and figuring out how to sort that out afterwards.
Is there any way to test that on the ground?
Testing what specifically?
Specifically ground.
I think it's just sifting through the data manually yourself, or doing just basic statistics and getting like a 25-75% and getting all the outliers like out. Any other questions? Yes.
So if you aren't a freshman or sophomore, you're still able to
Yeah.
join CubeCats.
Yeah, you can, if you do want to do our freshman sophomore project, we actually do recommend it for new members. So if you're interested and just want to get into the swing of things, we are letting anyone just join us anytime during the thing, during our process, because I understand that school always comes first, and you also don't see all the opportunities that you get straight off the bat. So if you want to join us, just go ahead and join us. And then after our freshman sophomore project, you transition straight up into our main project, which is the satellite, and you have your name on a satellite that will be flying up in space in 2 years, which is pretty cool. Yes.
Just final question. If anybody is more interested, is there a way to get in contact with the organization?
Yes, we do have an Instagram page. If you just search up UC CubeCats, it should instantly show up on Instagram. But email me, since I'm vice president and I always check my emails. I will give you all the information that you need at any point.
If you are following the IEEE Instagram, they are tagged in our most recent post.
Yes.
So you can find them there.
And if you have any more questions, actually, let me. Here is my GitHub, by the way, if you are interested. This is my GitHub page. If you want to see any of the Arduino stuff that I just put out today, and you somehow have this sensor or are looking to buy this sensor, I do have all the details on here. Funny enough, even though it is Arduino C, on GitHub it does list it as C++, but don't try running it in C++ because it will not work. All right, that's pretty much it. Thank you guys so much for coming.
Anybody wants more pizza? We have way too much. Please come grab
Thank you. That was a great presentation.
I try my best. It's been a hot minute since I've done this presentation. Like 6 hours.
Yeah,
It was not
but
good.
you be